Says live. Hello, ROS developers, and welcome to the 28th live class. It's 6 o'clock, 6 p.m. here in Barcelona, and then I'm Emerson Guaco, and I'm really proud, happy to bring you this class. This is the third and final class on the FlexBe series that we've been looking at for the whole of July, I believe. Yeah, I think for the past 3 weeks. Okay, so today's class is focused on container types, as I mentioned last week. And then we also, if there's time, we also look at the key mapping in details, but then I'm sure there will be time for that also. So you keep that in mind. And before we begin, I'd like to bring this to your attention. We'll be, on the Robotics Ignite platform. You remember that's where we keep all the courses that goes into details and all the stuff that you want to learn. All right, this month in August, we'll be publishing 2 different courses, one on OpenAI and the other on FlexBe. Much more details than the introduction you've received here. So without much ado, we're going to share the project for today's live class in the chat, and then we'll get started. So make sure you're logged into the ROS Development Studio, and then just click on the link to copy the project into your workspace. So once you have that done, let me know in the chat that everything is going on all right, and then we can get started. I'm going to do my best today to keep the speed really moderate, because we had some comments last week that I was moving too fast, and we'll do our best. Improve on it today. So go to the ROS Development Studio and then launch the project. Give me a thumbs up if you're done, and then if everything. Oh, wow. Okay, so I logged into the chat, and then Philip is here with us. Philip Schillinger, the creator of FlexBe himself, is here in the chat. So I think it's going to be a great class today. Okay, so I'm going to open my project, and then we can get started. A minute, Ricardo. Sharing my screen now, and then we'll get started. Open project. Okay, this is uncalled for. I'll be a minute. I think I'm experiencing some technical issues. My project is not launching. Let me know if you have your project open and then launched and then all that. So I'm going to log in. Wow, I thought I was already logged in. Okay, probably should work now. Okay, so whilst my project opens, let's recap on all what we've done up till now. On the first week on FlexBe, we looked at the states, how to create them, what makes a state in FlexBe, and then we also looked at the proxy publisher and the proxy subscriber cached classes. I hope you remember that. Then in the second week, we did proxy action clients, and then we looked at the autonomy levels. I hope you remember that one too. All right, so today's class, like I already said, container types, key mapping. Yeah, and then remember, we're still using the code that we've been using since the last live class. We just make a few modifications based on the new logic that we want to implement. So I'm going to share my screen now, and then we can get started for today's class, since we already are behind time. Okay, so you can go to the tools drop down and then click on Jupyter Notebook to bring up your notebook. I'm going to click on live class 28 because that's what we have now. And then we can get started. Let me see if there's, okay, everything is working. Ricardo says it opens for me. Yeah, that's great. Okay, so live class number 28 brought to you by me, Emerson Guaco, of the construct. This is all possible because of the construct. I hope you know that. All right, so why this class? Today's class is still, the final class on the robot behavior design that I've been talking about since the beginning of this class. And then previously, we've looked at the part 1, what we did in the part 1 and part 2 of the series. I forgot to mention the parameters that we did in the part one of the series. And then today we are adding in the input and output keys and then doing a little bit of key mapping when you're using the containers in FlexBe. So our aim for today's class, what do we intend to achieve? Well, it's still on introduction to using to the building your own robot behavior, but then we're going deeper with each series that we do. With each session, we go deeper. So today we may look at the state machine containers, concurrency container, priority containers, and then input output keys. All right, so we're going to begin with key mapping in FlexBe. All right, so far we've been using parameters, right? So, I mean, if parameters is doing the job for you, why bother with input output keys? Well, I'm going to ask you two questions. What if you want to pass the internal state data? I mean, the internal state of whatever class that you have during a transition to another class. Well, a parameter cannot do that for you. And what if you want any changes to whatever parameter that we have? Since we are using the previous classes, you know, we already have some parameters for each of the classes that we are using. What if you want to pass any changes that happens to them to the new state that becomes active? I think these are two major reasons why we need input output keys. All right, so before we delve further, there's one question that we usually come across. Someone will ask you, when do I use parameters, and then when do I use user data? That is the input output keys. Well, from Philips, a recommendation from Philips says that parameters are meant for choosing static values to allow for more flexibility than hard coding these values. Giving the operator some sort of flexibility to change one or two parameters before the behavior starts executing. And then literally parameters should be primitive Python types. And then when do we use user data? Just as I mentioned earlier, when you want to do some dynamic manipulation on whatever parameters or the state of a specific functionality. For example, a waypoint for a navigation state or the joint target for controlling a robotic arm or something. All right, so user data to you can use ROS messages as a type for them or primitive Python data types. All right, so going further, in order to implement this new logic, well, today we'll be modifying the go forward .py that we've been using that drives the robot, going straight. And then we also modify the turn_state py script to reflect the input and output keys that we're using. So if you've already been with us, you know that you can find the script in the Turtlebot behaviors inside your Captain Workspace. Remember to go to the source folder. And then, you know the hierarchy, Turtlebot FlexBe_state, then source in that, and then Turtlebot_FlexBe_state again. All right, there you're going to find these two classes. You can use the ID also to view them. So I'm going to go into the ID. Let me make this bigger. All right. So in the ID, for example, you go to Captain, the source folder, Turtlebot. Then in Turtlebot, make sure you go to the Turtlebot_FlexBe state. The FlexBe_behavior stores the behaviors that we've been dealing with up to now. And then you go one step further, two more steps further, then you see these two classes that we're going to be modifying. All right, so if you already have this, you can keep them, but then let's highlight on the changes that we're going to be making today. Okay, so back on the notebook. So what are we doing? In the go forward script, in the init, we're changing some few stuff. The new functionality here is we're adding in input keys. And then we're calling this input key remaining_travel_distance_in to signify that it's an input key when we are using it later. That's just a personal preference, but then you can do anything you want with it. And then we're also adding in an output key, which is a remaining_travel_distance_out to signify that it's an output key. All right, before I delve further, I want us to consider something. Why are we making these changes? Well, so far the robot drives the set target that we want. Let's say we give it 3 meters. I mean, we want the robot to travel 3 meters, right? Then when it encounters an obstacle, it makes a turn and then still drives 3 meters again. What if you don't want that kind of functionality? What if you want the robot to remember how long, I mean, how far it has already driven and then continue to make exactly 3 meters based on what has already occurred? So we want to know the remaining distance that the robot has to continue driving. To do this, the abstract of the whole thing is we're going to be storing the remaining distance inside the output key when the robot is transitioning. And then we are putting that into the turn state. But then in the turn state, we are not using it. We're just saving it over there and then bringing it back again when the robot transitions from the turn state after it has made a turn so that it can continue on moving it can continue on to execute and then finish whatever distance remains. So in this case, it will not be acting, like a dummy that we were using earlier, that the robot strictly has to make 5 meters, irrespective of how many turns it has made. This time, each turn that was made, we save the previous distance that was covered. So that's why we're going to be using input-output keys today. All right, so with the changes that I've made, and also remember we had this distance traveled that we're using in the execute function, which we'll look at next. Well, right now we're making it an instance variable so that it can be accessed from different parts of the class. And then if you were with us during last week's class, you remember we wanted to use the has message to be fetching, the recommendation that I talked of, that instead of using a callback, you can be fetching directly from the proxy subscriber cast. Well, I figured out the bug that worried us last week, and then it's been rightly implemented now. So now we have an instance of the proxy subscriber cast class here. And then in the onEnter event, remember when the transition occurs from the turn state back to the go forward state, remember the onEnter runs for each, whenever a state is about to become active. Well, what we want to do here is check if there is any data inside the input key, because the turn state will also be pushing out some data, whatever we passed to it previously, back into the input key for this class. So we check if there's any data, then we are setting that data to the travel distance that the robot has to make. So this way, we are always, updating the travel distance. Remember, we're using the travel distance as a parameter, right? When we start the whole thing, we're passing travel distance into the robot. The operator does that. But then now we are modifying it internally as the code proceeds. So those are the changes with the onEnter. And then in the execute function, as I was saying earlier, now we're using the has message. All right, you just pass in the topic to check if there is a message for this specific topic. So we just checking if there is a laser data. If there is, then we're using the get last message, the most recent message, and then we're saving it into the self.data, and then we're just moving on to do whatever calculation we were doing with it previously. Also, remember to call the remove last message so that always, anytime has message returns true, that means it's the most current message that we're going to receive. All right, so someone might ask, what was the bug that we had the last time? You see, I commented this line out over here. Well, I was using remove last message with this buffer also set to true. If you do this, that means you're clearing the buffer. But then remember, we've not enabled it, and so it was kind of causing some sort of internal error. That was what happened with the robot. Whenever it returned back, it was not getting any data on the scan topic. So remember to comment this one out, as I've already done here. And then let's, update our script and get started. So you can copy the code inside here. You do a Control A, and then Control C, and then paste it, in the same code that we've been using. So here I'm going to double click to open the go forward underscore state.py, and then I'm just going to copy Control A and then do Control V to paste the new code on top of it to override it. Okay. So let me make mine a little bit bigger. I hope you can see my screen. Let me check if there's anything. Oh, all right. So far so good. So in the go forward stage, remember when we started also, I talked about this dash dash to represent parameters. I mean, this is sort of a FlexBe kind of thing. Let's say it's, yeah, a FlexBe thingy. All right. So what is happening is if you want to represent an input key in your class, I mean the class string, well, you use a greater than sign with with a pound sign, okay, to represent an input variable. That's what I'm talking about over here. And then an output, you use a pound, I mean the reverse of it, the pound first, and then the greater than sign. Okay, so those are the only changes that we had over here. I just thought I'll point it out so that if you are doing your own thing, you know how to represent. I mean, someone can just look at this and know what figures, I mean, your class is going to use, and then what is happening here. All right, so we have this implemented. Let's go back to the notebook and then keep going. So in the right now, we're also going to be modifying the 10 state.py. Remember, this code actually causes the robot to turn around a specific angle that we've set for it. Okay. So what are we doing here? We also added in the input keys. We're calling this one a data underscore in to signify that it's an input key. And then the output key to signify that we're calling that data underscore out. Okay. So that's the only thing that we changed in the init part of this class. And then in the execute function, what we're doing is when the robot finishes turning around, okay, when it has done that turn that we want, let's say 90 degrees or 45 degrees, what we're doing is we're setting this data out because it will be before it returns the outcome, okay, before. So before this line over here, the return done. Okay, we are setting whatever data was passed to it through the input key to the output key. All right, that's what we're doing. We are not modifying whatever value came inside here. We're just passing it out so that it can be passed back into the go forward state. So the logic of the execute function has been described here. We looked at this last week. If you are new, you can read the logic that goes on inside the execute function and then catch up with that. All right, so right now we're going to copy the modified code, Control A, Control C, and then back to the ID. So right now, remember to save, so Control S, save, and then in the 10 state, I'm going to highlight everything and do Control V to paste my code. So now Control S to save. And just like the previous class, we used these indicators to show the input and the output keys as greater than, and then a pound sign, and then a pound sign, and then the greater than. Okay, so far so good, right? Let's get some FlexBe into the session. Okay, before we do that also, today, I mean, we've been using the Turtlebot simulation just as it is, right? But today, in order to visualize better the new changes that we're making, we'll be adding in 3 cubes when the simulation comes up. So we'll go to the simulations drop down and then click on Turtlebot 2. Okay, so we're just adding in 3 cubes on the left and the back side of the robot so that when it turns, I mean, there will be an obstacle in its path. And then so this way we can better visualize what's happening. I mean, how much distance the robot covered before it turned, how much distance is remaining for it to keep moving. So, well, whilst we wait for it, you can open 2 terminals because we're going to be having a, remember the server, the action server, so that the robot can turn around, and then 1 terminal to also be running the FlexBe launch. So I'm going to open the first terminal over here, and then I'm going to open a second terminal. Remember, everything is found under the tools drop down. Okay. All right, let me position that over here. Good. So before we continue, remember you first have to source the simulation workspace if you want to bring up the server. So, hey, why is this happening? Okay. So let's solve the simulation workspace. Just copy the command over here and then paste it in the terminal. And then, okay, that's done. You can also copy the ROS run vision follower spin server.py. This is the server that the robot will be communicating with to be able to turn around. Sorry. Okay, so back to the same terminal, the one you just sourced, and then paste it there to, get the server running. All right, let me get back to the simulation. Well, it's launched. All right. So right now we're going to be adding in the cube that I mentioned, to better visualize what we'll be doing today. So just click, remember the top right over here, click on cube, and then you can insert in a cube into the simulation. To act as an obstacle in the path of the robot. You can use any other shape, but then I chose to go with a cube. So, all right, that's the first three. And then we have the last three, on the back side of the robot. And the last one. Okay, so I hope everybody has their simulation looking something like this. It doesn't have to be perfect. You just need it on the left and the back side of the robot. All right. So moving on, before we bring up the FlexBe interface, remember we also have to source the cutting workspace. We've been doing this for the past 2 live classes, so you should be familiar with it by now. Just copy and then paste the code over here. And then to launch FlexBe, we do this. ROS launch FlexBe app, FlexBe_full.launch. And then in the same terminal where we sourced the cutting workspace. Remember the first time we sourced the simulation workspace, okay? Just paste the code here to start FlexBe. All right, so FlexBe is started and then we are not seeing anything. But if you've been with us for a while, you know you have to bring up the graphic tools. Yeah, so go to the tools drop down and then click on graphical tools. You can also use this overlapping rectangle over here to open it in a new tab so that we can have more space for the live class. So you can click login, click on the login button just in case you had the same issue of logging in like mine. All right, so let me know if everyone has the FlexBe running and then solve the simulation workspace. All right, so there's a question from Ricardo. It says, why do we have to solve the simulation workspace? All right, so this is the reason why we have to solve the simulation workspace to bring up the action server is because we defined a specific message that the action server will be using. Okay, and then the project that we have a custom project compiled. If you look inside the IDE, you see that down into the simulation workspace, we have this project called, in the source folder, there's a project called Vision Follower. Okay, inside this project, it has a custom message. It's called boundary. And then we are using this to, the custom message, it takes the speed that the robot should turn, the angle that the robot should make. So in order to get right now, if you run the action server without sourcing it, it will tell you that it doesn't know what message you're talking about. So we just do this to, how do we put it? Just update the current terminal workspace to know that, hey, this thing exists, so we can move forward with it. I hope I answered your question. And if I haven't, please do a follow-up and then we can get moving. All right. So, oh, sorry about that. With the graphical interface running, let's go to load behavior and then bring in the behavior that we've been working on till now. That's the drive forward. Okay, the drive forward. That's what we've been. That's where we left it last week. So I just did that, and you see a lot of errors because we've modified the class. All right. So let me check what's next in the notebook. Do we go ahead to? Yep. So the errors. Now we're going to do some key mapping. But before we do that, I'm back again. I'm going to explain this thing again. This is what we are doing. We want the input key for the go forward state, the remaining distance underscore in, to be mapped to the output key from the turn state. Okay. And then we want the output key from the go forward state to be mapped to the input key. So it's like we're feeding data from the drive state into the turn state and then back from the turn state into the drive state. That's what we want to do. Okay, so let's go back over here and then start implementing that. So to do that, you see that these errors are showing. This, how do I put it? This is FlexBe's way of telling you that, hey, the keys are not mapped. I don't know what to do with these input output keys that you have, okay? Well, output keys are not much of a problem, but then input keys are, because before the behavior starts, it needs the input key. If you've clearly specified that there's going to be an input key, okay? So to do the mapping, you come over here. Let's clear everything and then start typing data, and then you see that data underscore out just shows up because it's defined in the turnaround state. And then now it's available to any state inside of the behavior. You click on apply, you see that now we have something looking really good. And then we do the same thing for the remaining travel distance out, the output key. What did we say we wanted to be mapped to? We want to map that one to the data in. We want to be feeding whatever the remaining distance was into the turnaround state when the turnaround starts. So you just highlight everything, delete it, and then you see data in showed up. Remember to hit the apply button. Okay, so far so good, right? We are not going to touch anything on the turnaround state because we're leaving everything as it is. We want the data in to be, the values from the input key should be saved to the data underscore in, and then value from the output key to be saved on the data out. That's the only way that's why we're using the same figures over here. So if you changed this one over here, for example, if you call this data in underscore, let's say W, then remember to hit on the apply button. Let me do that again. Okay, my interface, yeah. All right, then this is what you have to do. Say you remap the name for the input key to something like data in underscore W. You hit on apply, and then you see now we have a new error because drive state it cannot find anything called data underscore in unless we do something like underscore W. So it's just the name. You can change the name to whatever you want. And then you see we did an apply and then everything is back to normal again. Okay, so we still have one error, the data out. Remember, we're mapping the data out from the turnaround state into the remaining distance, the input key for the remaining distance when the behavior starts. But then right now, before the behavior starts, what are we going to do with data? Because there's nothing on it, right? That's why we're seeing this error over here. Okay, so that's what we're going to do. We'll be mapping the target distance that the operator sets, okay, onto the data out. So when the behavior starts, let's say I give it 5 meters. 5 meters will be on the data out, but then that's only when it starts, the initial point. Further on, we will not, you remember we are modifying all those values. When it is going back and forth, the value will be changing. So to do that, go to the behavior dashboard, and then under state machine user data, that's where we're doing that, okay? What we're going to do is first, remember, make sure the name matches. So we're mapping data underscore out. Should be in caps, data underscore out. And then what do we want to map it to? So, so far, this is what the operator was modifying, right? The distance to travel. Well, we want to map the distance to travel onto the data underscore out. At the initial point when the behavior first runs. To do that, just use self. Remember to use self, else you're going to run into some errors. So self, then distance underscore to travel. When you've done that, hit enter, and then you can go back to the state machine editor and then if everything was done right, we shouldn't have any errors on the interface now. Okay, so far so good. Also, remember, we're seeing this data in, data out because we have the data flow graph checked. You see, when I uncheck it, it returned back to the normal state that we've been working with. I mean, the normal interface. So you can keep it checked to better visualize how the data is flowing between your various states. All right, so remember to save the behavior. And then now we're going to do a runtime. I mean, we're going to execute it and watch the log messages that comes out, because we want to better verify that the logic that we want is actually being implemented. So before you run that, remember to set the turn angle for the robot. I'm setting mine to 90 degrees because I want the robot to make a 90-degree turn when it encounters an obstacle. All right, so now I'm going to end the distance to travel also. Let's make it something bigger. So let me see. Let's go back to the behavior dashboard and then see the limits for it. Okay, my network is running a bit slower, but then I hope we can deal with it. So go to the edit. Let's edit the distance to travel. Okay, let me see the limits that we set for it earlier. Man, my instance is slow. All right, so the maximum was 5. That means we can set 5 as a value for it. Okay, so back to the runtime interface, and then let's set the distance to travel to 5. Let me check the chart if there's any. There's no question in the chat. Okay, so back to the runtime control interface, and then we can get started. So first set the angle, and then you set the distance to travel, and then we can get going. Okay, what's happening to my connection is very slow. I'll be a minute. I think I'm having connectivity issues. Yeah. All right. So I mean, switch the Wi-Fi access point, and then hopefully we're good. All right. Hopefully we should be back and then running live. Let me know if everyone can see my screen as it is now. Okay, good. So far, so good. I'm going to, okay. So I'm going to change the distance to travel parameter. I'm setting mine to 5, and then set the turn angle to 90 degrees also. So you can go ahead and then click on start execution to begin. So, well, to better enjoy this, I think we should go to the interface and then see the robot moving around, doing all the things that we, I mean, coded it to do for us. So right now, the robot is trying to make the 90 degrees turn and then later move on. I mean, continue executing until it has covered a place of 5 meters. Okay. When it is done, we will look at the log that was printed out to better analyze what happened. So right now, we wait. Yeah. Okay. So the simulation, yeah. And then, yeah. Okay. So it looks like the simulation is done. Yeah. The behavior ended successfully. All right. So before we move on, however, today there will be a 10%. Okay, Ireland is a 12% discount. Yes, we'll be posting the code in the chat session, and then you can use that in the Robot Ignite platform, okay, to access any of the courses that we have over there. So the behavior finishes executing, and then we're going to look at what happened. So you can come to the behavior feedback panel session over here beneath everything, and then let's analyze it. So when it first started, what was it? Remaining distance to travel was 5 meters. That's the initial value that we used, right? Okay. Then the robot started moving around, and when it encountered an obstacle, it started turning around. So that's why we have current heading. It was printing out the heading of the robot as it turned around. So the moment it finished turning, well, it transitioned back to the drive forward, the go forward state. And now you see that the distance to travel has reduced because the robot went a certain distance before it encountered an obstacle. So now it's what, 3.884 meters more, to go. So far, the distance that was remaining to go. Then it tried to achieve that. And then whilst it was doing that, well, let's see if it encountered an obstacle. It did. So it says drive forward ended, and then it transitioned back to the turning state to turn again. Because remember, the logic we are using says whenever it encounters an obstacle, it needs to transition to a turn state and then turn the robot around, right? So it did the turn for us, and then transition back to the go forward state. This time, the remaining distance was what? 2.3088 meters. So if you've been following, you know that the remaining distance keeps reducing because the robot has actually been trying to move, to reach the target, but then the only thing is there are some obstacles. But then in the end, it does that for us, and I think this should be the final, lap for the robot, and it completed the 2.3088 meters for us successfully, and then the behavior ended. So you see, as I mentioned earlier, input output keys for dynamic use of internal state data. That's what we just did. Anytime we're just calculating the distance you travel and then passing it out when the transition left the current state, and then bringing it back in when we were coming back. So nothing special, but then just dealing with dynamic data. So let me know if anybody has a question regarding what we've done so far before we look at the container types for FlexBe. All right, so the chat session looks clear for me. All right, let's move on. So over here is a description of everything that we did up until now. So we're looking at container types. All right, so for simplicity's sake, think of a container as some sort of box that governs the organization and then the order of execution of various things. So let's say the parent container should be the red container that we have over here. And then you can think of these boxes as individual states or containers themselves, because when you look at the features for a container, you know that they can contain other containers, or in this case, boxes. And then they can also contain entire behaviors. But then one thing that differentiates them is that each one has a unique way that it operates. So for example, we look at the state machine container that we've been using. By default, what we've been using is the state machine container. The special thing about the state machine container is that the output of the state machine is actually a function of the input and then the current state of the robot. So, for example, when we transition to the go forward state, the output was based on the remaining distance to travel. And then if there was an obstacle in its path, or if it had finished the target that we set for it. So the current state, the input, and then what the current state and then the input. That's what this depends on. So that's the basic state machine that we've been using. There's a diagram here better explaining it, for clarity's sake. And then there is the concurrency container. Okay. So what we've been doing so far, we've been dealing with sequential execution of behaviors from step 1 to step 2 to step 3. What if you have a behavior, okay, that you want 2 different states to be running at the same time? Well, that's why we have the concurrency container. It does this for us. So in the concurrency container, all states are active at the same time. All right. Yeah. So we have That's a parallel execution. So, in what instances are you going to need a concurrency type container? Well, for example, a robot should perform a sequence of actions. Let's say move forward, turn around, and all that. But then in parallel, we want to also monitor certain sensor values. So what we did, putting all those code inside the go forward state. You remember forward state, we had a check-in on the scan topic to see if there's an obstacle. You could actually separate that into a different state on its own and then have the robots, execute them in parallel. All right. And then the last container type is a priority container, which is exactly the same as the default state machine container, but it comes with some sort of preference. That's what I like to call it. Because, for example, what do I mean by this? So, given, for example, you have three, container types. There's container type A, B, and C. Three state machines. So we denote C as a concurrency container type, all right? And then A is a state machine container type, the default one, and B is a priority container type. All right, so in this example, we have A and B contained inside of C. According to the definition for C, what should happen is when this container runs, actually A and B are supposed to execute at the same time, right? But that's not going to happen because we have a priority container inside here. So what is going to happen is B is going to finish executing and return before A can execute, even though they are inside the concurrency container type where there should be some sort of parallel execution. So let's go back to the graphical user interface, and then let's see some of these in practice. This whole container type thing, let's look at it more further in practice. So you can close the simulation because we'll not be using that. And then my graphical interface, reconnect. Okay, so my connection is very slow today. I apologize for that. I'm really sorry. I didn't see this coming. Okay, so log in and then give me that interface. Okay, first I'm going to close this tab and then reopen it again. That should give me a better interface. So, yeah, it's just the chat. Okay, so all right, I'm back in the comments. I had to pause and rewind a bit, so I'm about 5 minutes behind. All right, so okay, so the Felix saying that she was able to follow the instructions and then got the robot to turn 90 degrees. Oh, that's great. All right, so let's go back to the graphical user interface and then I'll try to demonstrate the container type that we've been talking about so far. Oh man, my connection is really bad today. I really wish this wasn't happening, but okay. So finally, I'm logged into the graphical user interface. Right now, I have to wait for FlexBe to come back because I restarted it. All right. So while we wait, this is what we're going to do. I have some set of behaviors already defined that there is a concurrency container, okay, and then inside it, we're just looking at the final example that I mentioned over here, where we had three state machines, A, B, and C, and then A is a basic container type and B is a priority container type. All right, so we're just going to look at that in practice. And then, to better feel, man, why is, no, I don't think this is happening. Okay, so for some reason, my network, whoever is sucking the bandwidth is not doing me good. But then, yeah, so wait. Hopefully, if I'm able to get onto the interface, I'll get to show you that. Let me see, we have about 20 minutes to go, so there's time. And then let me try to reconnect. Oh, this is no good. Oh, okay. So we have it. So, yeah. All right. So finally, the interface decided to work for us. I'm really sorry about that. I don't know what's happening with my network today. Everybody is still here with us. Okay, so let's go to the load behavior, and then we'll be loading in this behavior that I had already coded. I call it the container testing. Yeah. So if your panel is showing, you can click on that. You can actually use the second one. I think there's a one and then a two, but my network is really, really not permitting me to do a lot today. Again, I really apologize for this. Oh, okay, it showed up. Container, so you can just select containers two, the number two over here, and then we can give in. But then, well, sorry about my bad connection, but then if anybody has a question based on the explanations that we've done so far, you can post them in the chat session, and then I'll do my best to answer them. Philip is also in the chat, so even if there's anything I couldn't tackle, I'm sure he'll be the best person to tackle your questions. So, it's question and answers time. Please post your questions over here. Just anything you want to know about FlexBe, any doubts, anything in your mind anything that bothers you based on what we've done so far, or based on something you've been reading about FlexBe that you want further clarification, you can post your questions over there, and then we'll do our best to help you with it. Well, my network is very bad. I'm not sure I'm going to be able to demonstrate this today. But regardless, if I'm not able to demonstrate it today, we'll be posting maybe a 5 minute, 10 minute video showing what I was supposed to do now, but due to my connection, I'm not able to do it. Okay, so bear with me on this. All right, so assuming we did that and everything, I think that's the final session for the class today. We looked at key mapping. In fact, so far we've done almost all the basics that you need to define a logical behavior for your robot, to get a robot to behave in a certain way, to design a specific behavior. We've looked at how to create a state, proxy, the various proxy classes that FlexBe presents us. Well, I know we didn't look at the service, the proxy service request, but it's exactly similar to, they all have the same interface. You pass in the service name and then the type that is going to expect, just like you did with proxy action clients. We've looked at key mapping, and then we just looked at the container type. So, so far, you should be able to do anything you want with FlexBe. And on the advanced courses that we're going to be publishing this month, we're also going to be delving further in using FlexBe. We will look at the code generation behavior aspect of FlexBe. We will be looking at so much more. How to test your state, how to write unit tests, for everything. And then, so without much ado, question and answer session. How much? Yeah, I have like 5 minutes to go. So I'm going to be here, and then please post your questions, your doubts, anything you want to know, anything you want us to talk about. And like I said the last time, if you have a specific topic that you want us to talk about, if you've encountered something that you think we should make a live class regarding, you can post it in the comment section, and then based on the number of votes, the likes, and then number of people that support your idea, there's a high probability that we'll tackle that for you also. So without much ado, I think this will be the end for the class today. If there is no question, and then see you when I see you. Bye.